Hey, what's up, guys? It's Mr. Gagnon. I'm going to talk a little today about something called scientific notation. Um, so, in science and in math, we have a way to write numbers that are really large, and we can kind of shrink it up a little bit. Or really small. So let's start with a really large number. Okay, I'm going to give you guys a heading for your notebooks. Okay, the heading reads scientific notation. And so let's give you some rules here. Okay, rule 1. The base number, I'll explain what that is in a second, can't be bigger than, we'll actually say 9.9. Okay, base number can't be bigger we'll say smaller than 1. Okay, let's talk about base numbers. All right, so here's what we call a base number. Okay, that's a base number. And we're just multiplying it by a larger number there. All right, so let's try one. Okay, here's our example. So we got a number of 155. We want to get that into scientific notation. So we've got to take our rule that the number can't be bigger than 9.9, can't be smaller than 1. So the base number has to be, is it 15.5? Nope. Is it 1.5? Well, yes, it falls between 1 and 9.9. So our base number is 1.55. And then our exponent tells us that we moved it over 2 spots, so it's times 10 to the second. Pretty easy, right? So 1.55 times 10 to the second. And that's for a large number. And we can go with really large numbers and just have this number get larger and larger. All right, let's try a small number. Okay, well, we're going to work with 0.025. Our base number is going to be between 1 and 9.9. So let's move the decimal this way. 0.25, are we there? Nope. Okay, are we here now? We moved it over twice. Yes, our base number is now 2.5. You don't need that 0 anymore. 2.5 times 10, and now except, here's another rule. When we have numbers that are large, the exponent is going to be positive. When we have numbers that are small, the exponent will be negative. So how many times we move over? 1, 2. So answer, 2.5 times 10 to the negative second. Okay, and that's a basic explanation of our scientific notation. One more example would be, let's just look at the number of miles to the sun. The sun is 93 million miles away. We got to get that into scientific notation. So again, the number is going to be between 1 and 9.9. So we move this decimal over once, twice, 3 times, 4, 5, 6, 7. So we got a 9.3 times 10, and we moved it over 7. And that's a positive 7 because the number is large. So this is our answer in scientific notation. Again, this is something that you should probably have learned in math class, but again, it's just going to be a little review for you guys in that case. So let's just try one tiny number. Okay, I don't know what that represents, but it's just a number that's small. Where you want to get the base to be here, because between 1 and basically 9.9. 1, 2, 3, 4, 5, 6. So we got 7.2 times 10. Again, the number is tiny, so we go on negatives, negative 6. Okay, so that's how that works.